So this example is kind of similar to the last one, except that we now have three groups. We have a child, we have adult, and then we have senior. The question said that if we have 100 child, then 4 will enter adulthood, and then 2 will die. So 2 will pass away and not go to any group. So what that means is 94 will remain children. Now, if I have 100 adult, then 1 will become senior, 1 will become senior, and then 1 will die. So what that means is 98 will remain an adult. However, there will also be 3 newborn babies in the next year. And for every 100 senior citizens, I'm gonna have that 2 pass away. So 98 remains a senior citizen. So if we look at the numbers that we have here, what that means is in the next year, I'm gonna have 94 plus 3. So that will be 3 newborns. So 94 plus 3 is going to be 97 children. And then I'm gonna have 4 plus 98. So I'm gonna have 102 adults. So 98 from the adult last year, and then there will be 4 new adults from the children that grows up. And then there will be 99 senior. And the question said what's going to be the demographic in the long run. Now this is a little hard to guess, so let me just pull up my Python. Let me actually just copy and paste my old code from earlier. So now my matrix A is gonna have 3 columns. It's going to be 100 children, 100 adults, and then 100 senior. Remember again that in Python, the column will start with column 0. So I'm going to have column 0 be the children, column 1 be the adult, and then column 2 be the senior citizen. I'm going to have my A, my B, and then my C. So this is going to be the number of children, adult, and senior in the next year, and then that's going to put that next to my old matrix A. So the number of children in the next year is going to be just the number of children last year times 0.94. So I'm going to multiply this by A of I and 0 plus 0.03 times the number of adults last year. So that's going to be A times I1. And the number of adults in the next year is going to be 0.04 times the number of children last year. So that's going to be AI0 plus 0.98 times the number of adults last year. So that's going to be 0.98 times A of I1. And then the number of senior next year is going to be 0.01 times the number of adults last year. So that's going to be AI1 plus 0.98 times the number of senior last year. So that's going to be A times I2. So let me actually just do 5 years first. Okay, let's see what happened. So I start off with 100 people in each group, and then I'm going to get 97, 102, and 99, which is the number we have from earlier. And this is what happened in 5 years. So let me actually run this to 100 and let's see what I get. So after 100 years, this is the number of population that there is going to be about, let's see, 62 children, 124 adults, and about 66 or almost 67 senior. This is still a little hard to look at. So let me actually just run this to 8,000 years. Let me actually go back to my code from earlier. Let me run this to 1,000 years and let's see what we're gonna get. Okay, it seems like there will be about 62.5 children, 125 senior, and then 62.5 adult. Well, the question actually doesn't say what is the initial number of children, adult, and senior. So if I were to change this to 1,000, that should get rid of the decimal that we have. Yeah, so we have about 625 children and senior, and we have 1,250 adults. Notice that the proportion here is actually going to be 1 to 2 to 1. The number of children and the number of senior is actually the same, and that's half as much as the number of adults. And if I actually try to change this number, let's say if I have 20 children and 100 adult and let's say like 1,000 senior, let's see what's gonna happen. The number that I have is actually still gonna be in the same ratio. It's gonna be 1 to 2 to 1, and I can actually try to change this no matter how I want. I can try 1,000 here, 100 here, and then no senior citizen. Let's see what I get. Yeah, I still kind of get the 1 to 2 to 1 ratio, except for the case that I start off with just the senior citizen. So it kind of makes sense. If I only have a senior citizen to begin with, then the population will just die out. Or, well, I can also try, like, let's say if I have just one children, one adult, and then one senior to start off with, it's going to be just a fraction anyway. Yeah, so it's still the ratio is 1 to 2 to 1. So it seems as if the demographic in the long run is going to be 1 to 2 to 1, or it's going to be just 0 to 0 to 0, so everyone just dies out. So we're going to see why this is the case later.